All right, everyone. Hopefully you watched the 10.4 warm-up. If you haven't, please go watch this warm-up and work through these 10 problems. It's a quick review of trig functions and evaluating trig functions for ratios. That'll help this lesson make a little more sense when we're finding the inverse of trig functions. So on that warm-up, we talked about the definition of a trig function again. This is what we were working on right before Easter break, where in a trig function you're given an angle as your input and you are finding the ratio of the side lengths depending on what trig ratio you're solving for: sine, cosine, tangent, and all the reciprocals. Okay, now just the opposite when we are given for the inverse. Remember, we've talked about inverse functions before. It's where our inputs and our outputs just flip-flop. So now we're going to be given the ratio. And from that ratio, we're going to find the angle measure. And remember, angle measures, they can be in degrees or they can be in radians. Okay? So, an example for what each of these look like when you're finding or evaluating a trig function: the sine of 45 degrees. Remember, go through your steps like we did on the warm-up. 45 degrees, find your reference angle. 45 is already your reference angle. We know that a 45-degree reference angle is always going to give us, for sine and cosine, root 2 over 2. If you punch this into your calculator, you would get 0.71. Okay, so now doing just the opposite, where we are solving for the ratio given, we're solving for the angle measure given the ratio. So now you might see something like this. Sine of theta equals root 2 over 2. Meaning, what angle measure gets you root 2 over 2 for a side length of, we're opposite over hypotenuse, where your ratio is root 2 over 2, and we know that theta equals 45 degrees. You can also put this in radians. Theta equals pi over 4 radians. Okay, another way you might see this is you might see the inverse. Remember this, to the power of -1, that means inverse sine of root 2 over 2. And that's just asking you to do the same thing. What angle measure gets you a ratio of root 2 over 2? Oh, that would be 45 degrees. Let's try one more before we go do these examples. I'm going to slide all of these up, and we'll do one more. Okay, let's do cosine of theta gets us 1/2. Let's do -1/2. Okay, well now we're going to be working backwards here. We want to know what ratio gets us 1/2 for a cosine trig. What angle measure gets us a ratio of 1/2 for our cosine trig function? Okay, remember, sine of theta, we wrote this on the warm-up, is y, cosine of theta is x, and tangent of theta is y over x. So we want to know, where is our trig ratio for cosine? -1/2. Well, if it's negative, and you know that negative is a negative x value is our cosine trig ratio, that means we need to be over here in these two quadrants, because that's where x is negative. X is negative in quadrants 2 and 3. Then we want to construct an angle measure that's going to give us an x value of -1/2. If you remember, 1/2 and root 3 over 2, those both come from either a 30 or a 60 degree reference angle. So if this is my reference angle, theta, I know that this angle theta has to be 60 degrees. So theta here is 60 degrees because the side length opposite of 60 degrees is root 3 over 2. So if my y is root 3 over 2, that means I know my x coordinate is 1/2 for both. So that means that 60 degree reference angle is going to get you the two angle measures for theta where you would get negative 1/2. Okay, so that would be 180 minus 60, 120 degrees. And I have two answers here, 180 plus 60, 240. Okay. And then remember, these are functions. You have a calculator. You can check your work here. If we punch in the cosine of 120, we should be getting negative 1/2. That checks out. If we punch in the cosine of 240, that gets us negative 1/2. Okay, I'm going to show you in a sec, later in this lesson, that you could also just hit this function option, and on your graphing calculator, I think it's just hitting second and then cosine. Now you have the inverse cosine function, and you could punch in negative 0.5. There's just one potential issue here. Your calculator is only going to give you one answer, so you would need to know and use what you know about reference angles to find this second reference angle of 60 degrees in quadrant 3, where x is also negative. Okay, and we'll keep practicing that throughout this lesson. Okay, let's try a couple more. Let's do numbers 1, and we'll do a tangent 1. Numbers 1 and 3, and then I'll let you work through the rest of these. Okay, cosecant. Cosecant of theta. Remember, cosecant is the reciprocal of sine, so what this is really asking for is the sine of what angle gets us a trig ratio of 1/2. Great, let's go ahead and ask ourselves, where on this unit circle does sine need to be positive? If we know sine is y, that means sine is positive in quadrants 1 and 2. And then again, you use what you know about reference angles. We want the y coordinate to be 1/2. So that's going to be a little bit shorter than root 3 over 2. Okay, so our reference angle is going to be 30 degrees because the side length opposite of a 30, 60, 90, remember that would make this 60, would be your 1/2. And we want our y coordinate here, because sine of theta, sine of what angle is going to get us 1/2. We want this y coordinate to be 1/2. So our two angle measures here would be 30 degrees and a reference angle of 30 in quadrant 2, 150. Remember, that just came from 180 minus your reference angle of 30. Okay. The directions say give your answer in radians and degrees. It's good to practice both. Remember, for 30 degrees, that would be pi over 6. 30 degree increments are pi over 6. So if 180 is 6 pi over 6, just subtract a pi over 6, and you have 150 degrees. And once again, use your calculator to check your work. We could just enter the sine of, let's try it in radians. Switch our calculator to radians. Pi over 6. And we get that 0.5. Sine of 5 pi over 6. And we're also left with 0.5. Okay, use your calculator to check your work. Okay, let's try 3. Just written a little differently. Remember, it's still asking for just the inverse tangent trig function. So we want to know what angle measure gets us root 3. If you remember, tangent is y over x. So that means we have two options. It's not going to be root 2 over 2 over root 2 over 2, because that's just going to get us 1 every time. So it's not going to be a 45-degree reference angle. It's going to either be a 30 or a 60-degree reference angle. And let's check which one. Root 3 over 2 over 1/2 or 1/2 over root 3 over 2. One of these two complex fractions results in root 3. And we'll quickly see which one is the case when we multiply by the reciprocal. And perfect, we're left with root 3 over 1. So we want to know when the y is root 3 over 2 and the x is 1/2. Remember, tangent is y over x. Okay, so let's quickly sketch our unit circle here. The two quadrants where tangent is positive would be quadrant 1 and actually quadrant 3, because a negative over a negative gets us a positive. And we want to know where the y is root 3 over 2. So that means we need a pretty steep reference angle, because y needs to be root 3 over 2, so a 60-degree reference angle. And actually the same down here. 60-degree reference angle, root 3 over 2, because that would make our x-coordinate 1/2, 1/2. So our two angle measures here, let's put these in radians. 60-degree reference angle in radians would be 2 pi over 6 or pi over 3 radians. And all of this was 6 pi over 6. And we add 2 more pi over 6 radians, we would be at 8 pi over 6 or 4 pi over 3 radians. Okay, why don't you guys go ahead and sorry, one more thing before you work through these next 4 problems and you pause the video. Remember, secant's the reciprocal of cosine. So here you're solving for the cosine of theta. Cosine of what angle gets us a ratio of? Just flip this. Negative 3 over 2 root 3. Multiply top and bottom by root 3. We get negative 3 root 3 over negative 3 root 3 over 6. And then hopefully you see this is just negative root 3 over 2. Okay? So whenever you see that negative 2 root 3 over 3, that just came from the ratio of root 3 over 2. Okay, go ahead and pause the video, work through these next 4 problems. I'm going to put the answer out. Remember, you should be getting 2 answers, and you should be putting them in degrees and radians. Okay, for number 2, you should have gotten 30 degrees and 330 degrees. Our answers in radians would be pi over 6 and 11 pi over 6. Okay. I'm not going to work through these for the sake of time. If you guys have questions, we'll come back and answer them during our Google Meet office hours. For number 4, this should have gotten you 150 degrees and 210. If we are in radians, 150 is 5 pi over 6, and 210 is 7 pi over 6. All right. There's only one answer for number 6, 90 degrees or pi over 2 radians. And then, great, for number 5, I will show you how to work out number 5. I showed you one like this on the warm-up where your ratio is not one of our ratios from a 30, 60, 90 triangle. So here you have to use your calculator. You need to enter the inverse cosine of negative 0.123. And your calculator tells you you get, oops, I'm in radians, make sure you're in degrees. Your calculator tells you that theta is 97, let's just say 0.1 degrees. Great, that's one of your answers. Your second answer comes from using the reference angle. So if 97.1 was this angle, my reference angle is 180 minus 97.1. So a reference angle of 82.9. And if I want the other trig ratio, or sorry, the other angle measure that gets us a negative trig ratio for cosine, that would have to be another reference angle in quadrant 3 because cosine, your x values are negative in quadrants 2 and 3. So you just do 180 plus 97.1 to get your, sorry, not 97.1, plus your reference angle of 82.9 to get your second angle measure that would result in a ratio of negative 0.123. Okay, if you guys have questions on these, ones that I didn't go over, we can answer them during our office hours. Okay, that's really it for this lesson. The one thing I want to finish up with is just a quick revisit on what our definition of a function is. Because there's one problem with every single answer we've been solving for in numbers 1 through 6. Remember, a function is when there is one output for every one input. Okay. There cannot be two outputs for one single input. That's not our definition of a function. Well, there's a problem with that statement in our definition of a function, numbers 1 through 6. Hopefully you guys notice we keep getting two answers for all of these one inputs. Remember, these inputs now are the trig ratios. Trig ratio 2, trig ratio of negative 2 root 3 over 3. Keep getting two different angle measures for both, and because that's the case, we restrict domain, meaning what our inputs can result in for these inverse trig functions, to make the inverse a function. And if you don't want to write all of these down, this is what I'm referring to, these restrictions. I think it's nice and easy just to see, look at this image here that shows which quadrants are shaded. That's where the domain is going to be restricted to. You can just copy and paste this from the book because that's what I did. Okay, so now when your directions are to solve each equation to the nearest tenth, use the given restrictions. Well, if you don't have any restrictions like number 1, you're going to use these restrictions up here. Number 2, you have your own set of restrictions here, and I'll show you how to use those in just a sec. All right. Okay, so for number 1, sine is restricted to the two quadrants on the right, quadrants 1 and quadrant 4. Great. That's only going to give us one answer because here our ratio for sine is positive, and that means a positive ratio for y needs to be in quadrant 1, and I would just go ahead and enter the inverse sine of 0.4, gets us an angle measure of 23.5. It says round to the nearest tenth, so 23.6 degrees. Okay, we're not going to use quadrant 4 because the ratio here is positive. If you went down here in quadrant 4, that would mean you're using a negative sine ratio. Right, for number 2, it's now restricting. If it gives you the domain restrictions, you're not going to use the ones up above. You're going to use the ones that the problem is restricting the domain to. So now the domain is restricted to greater than 90 and less than 270. Okay, and then you just ask yourself the same question. Out of these two quadrants, where is y positive? Because our ratio, again, it's still 0.4 is positive. Well, this one up here, the top one, y is positive in quadrants 1 and 2. And then you would just use a reference angle of 23.6 degrees. And that would be our answer to number 2. 180 minus 23.6 degrees gets us an angle measure of 156.4 degrees. Okay, so why don't you guys try that for numbers 3 through 6. Just keep in mind on numbers 3 and 5, when the restrictions aren't given, you're using the ones up above, okay? All right, go ahead. Put the answers up after you unpause. Okay, so for number 3, we should have gotten theta is 53.1 degrees. Remember, cosine is restricted to top 2 quadrants, and the quadrant where cosine is positive is quadrant 1. X is positive in quadrant 1. Number 4, using a reference angle of 53.1 degrees in quadrant 4 would have gotten you 306.9 degrees. Just doing 360 minus 53.1. For number 5, what angle measure gets us a tangent trig ratio of -2? Tangent's restricted to these 2 quadrants when it's not given, right? Go up here and look at this chart. Tangent is restricted, just like sine, to quadrants 1 and 4. So theta would have gotten you -63.4 degrees. Great. We want to keep it negative instead of using the coterminal positive angle. And then using a reference angle of 63.4 degrees in quadrant 2 would have gotten you 116.2 degrees. Sorry, 116.6 degrees. Once again, guys, you can always check to see if you did this correctly. Just enter the tangent of 116.6 and look what your answer is. Basically -2. It's not exact because you had to round to the nearest tenth. Okay, almost done here. Secant. Remember, secant is the reciprocal of cosine, so you're really just finding the cosine of what angle would get you a ratio of this reciprocal. The reciprocal of 1.2 over 1 is just 1 over 1.2. And when you enter the inverse cosine of 1 over 1.2 on your calculator, you get, I don't think I've done this one yet, inverse cosine of 1 over 1.2 gets us 33.6 degrees. And then just make sure you're in the correct quadrant. That's restricted. Yep, you're told that you have to be in quadrant 1, so that checks out. Okay, and I just want to finish with one problem because we're going to be solving all triangles later in this unit. And now you can solve for any angle measure in a right triangle using the inverse relationship. If you're looking at this word problem, the Tower of Pisa is leaning, it's about 13.5 feet horizontally compared to the base, and we want to know how many degrees does the tower tilt from vertical. So we're really solving for this angle measure right here. How far from vertical? Well, if you're using that angle measure, you have the side length that is opposite and adjacent. So we're going to be using our tangent trig function. And we would just enter the tangent of what angle gets us an opposite side length of 13.5 over 154. And then on your calculator, inverse tangent of this ratio, and you get that angle measure. Theta is 13.5 over 154. The problem says round to the nearest degree, so we would say the tower tilts about 5 degrees from vertical. Okay. You might have a word problem like that on your homework. Just set up a trig ratio, use the correct trig function depending on the side lengths that are given. Here it was tangent. And then you use your calculator. Remember, going to this function gets you to these inverse options. Tangent, cosine, sine. All right, I'm sure there'll be questions. Check the schedule that I posted on Schoology under updates. We have office hours twice this week to find your given time. And I look forward to seeing you guys there.